All right, welcome everyone. In this video, we are going to begin our next module that covers data structures in our matrices, arrays, and lists. So far this semester, we've been working in large part with vectors and data frames as our main storage object for data. Vectors, these are one-dimensional objects that have a single data type. So I can have a vector that has all numerics, all logicals, or all characters, but I can't have a vector that has some elements that are numeric, some elements that are logical, for example. So a vector is a homogeneous data structure that can only contain a single data type. Data frames, these are two-dimensional objects. We've been storing our data in tidy fashion so that each row is an observation and each column of our data frame is a variable. And each of these columns has to be a single data type, but different columns can be different data types. So a data frame can contain different data types. That's different from a vector. In this module, we're going to focus on matrices, arrays, and lists. So these are three additional data structures in R that are very often used to store data and other information that we want to analyze. So these data structures are really fundamental to doing data analysis in R or Python or any other programming language. Matrices are perhaps the most fundamental object throughout all of mathematics, whether that's coding, whether that's doing theoretical mathematics and working with bases and other more theoretical constructs from linear algebra. Matrices are front and center in mathematics. So I highly recommend taking an entire course in linear algebra and learning all about the theoretical properties of matrices. That's not what our goal is in this module. It's going to be how do we interact and do matrix algebra in R? How do we store data in matrices? And then how can we do some arithmetic with the data that is being stored in our matrix? So matrices are great for storing information, and then we can do some arithmetic with our matrices to actually construct some modeling and do regression analysis, do machine learning, all of these really powerful fields in data science are built with matrices as the foundation. So it's really important to get a good understanding of working with matrices in order to do data science. So before we get going in this module, I want to just point out that there is a link to this Colab notebook in the description of this video. And we're going to load a couple of packages that we're going to need for this module now, and then make sure that you've got these loaded when we get into the videos that follow. But this first code cell is going to install two packages, the micro benchmark package that we'll use later on, and the abind package. These are two packages that we'll use later in this module, so we won't see them right away. And once that finishes running, I'm now going to load these three libraries. So I'm going to load the tidyverse, which is going to load a whole bunch of packages that we'll use. We'll load the micro benchmark, and we'll load the abind packages. And I just want to remind you, we've been working in RStudio a little bit, and now we're back to working in Colab. And so when you're working in Colab with R, it works a little differently, that you're going to need to install the package every time you restart a session. And that was not the case in RStudio. In RStudio, you can install a package and it stores those files locally on your computer. And then each time you want to use that package, you just need to load it with the library command. But that is different in Colab. In Colab, when you install these packages, it downloads the files temporarily, and you can load them with the library command. But once your session times out or you get disconnected, those files that you downloaded get cleared and you need to install the package in Colab again. So in this case, the tidyverse package, it's already installed in the kind of default Colab notebook for R. So I don't need to install tidyverse, but micro benchmark and A-bind, these are not by default installed in Colab. So that's why I need to run the install package command and the library command to access these packages. And I need to do both of those steps every time, install the package and load it with the library command. But once you've run these first two code cells, you now have all of the packages that you'll need to run the rest of the code cells in this notebook.